You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of Complete Developer Podcast. This week, we're talking about principles of object-oriented programming. OOP, or object-oriented programming, has four major principles: abstraction, or using a focused representation of an actual item; encapsulation, hiding the internals of an object; inheritance, reusing code from an existing object; and polymorphism, one name, many forms. But before we get started, Will, what have you been fighting this week?
Well, I've not been fighting so much as I'm digging the fact that Microsoft has released ASP.NET Core, .NET Core in general. Now, their tool chain that goes around it is still in preview, but they've actually released the product. And so, I've also been playing with Node. And so I'm back and forth on which direction I want to go because I've got a lot of years of experience in C#. And for my side projects and things, like I could go on ASP.NET Core and I could continue with Visual Studio until such time as, JetBrains releases an IDE, and then I can jump across platform. Or if Microsoft releases one on Linux that actually holds up to what I need. Visual Studio Code is not quite there.
It's not an IDE. It's a code editor. That's not what it's for, though. You can add,
and I've been using it for Node like crazy.
Yeah, I have too. And you can add enough extensions to it to make it very similar.
Yeah, but
it's just not.
I don't like that build your own. Like, I'm not a build a bear workshop kind of guy, and I would rather go buy the thing working and not fiddle with trying to configure it, which is one thing that's kind of kept me off Linux for a while. Is I need a configuration that works well enough for me to get something done, because my focus is not on the platform, it's on producing something with it.
See, that's funny, because that's one thing I like about Linux.
I like being able to customize, and Windows gets in my way a lot with that. But the other side of it is I have a reasonable assertion that if I insert a Windows disk and say, okay, here's my monitors, here's my setup, that I can get there fairly quickly. Whereas with Linux, I've always had problems with graphics drivers on there, and it's better now. And I've got a way forward with my rig on my desk. But
that's really funny, because with my crap top, as you call it, the Linux OS I have on here works better with my graphics than Windows.
Right, but you don't have two graphics cards driving four monitors.
No,
and have to be able to drag windows between them and all that. And it's getting there. It's very, very close. And I really want to be off the Windows platform, because I feel like it's not Microsoft's real focus. They just got sued, actually. There was a woman that had I think it was a flower shop or something, and they tried to force a Windows 10 upgrade on her, and it slowed her business to a crawl for several days. And, it was cheaper for her to buy a new computer and move her stuff over to it, so that, business continuity and all that, because you've got deliverables. And she sued Microsoft and got $10,000 out of them for their forcing of Windows. And there's a lot of things I'm seeing on that platform that I'm really, really getting disturbed by.
I just don't understand the whole forced upgrade with Windows 10.
Well, it's easy. It's a support thing.
I understand it from that side of it, but Microsoft knows better.
They should. There's, I get the impression that there's a lot of back and forth inside their offices. Like they're different. There's conflicts of interest, or there's major disagreements at an executive level on what needs to happen next, because like the .NET team is producing some really, really awesome stuff, and it's open and it's accessible, and works cross-platform, and they're bringing other partners in, and they're doing things and going, okay, yeah, you can upgrade when you feel like it's the right time. We're not going to force you to do that kind of stuff. And then you have things like Windows that are, where the people in charge there are just going, yeah, we're just going to force you to upgrade. And, if it shuts your business down, we don't care. And it's very user hostile, and it's not good. And the more of this kind of stuff I'm seeing that, and then I'm seeing that.
Makes you wonder if maybe down the line there's going to be something not Windows come out.
Yeah, that does.
They've got another OS that, they're going to make Windows so
awful that people actually want to make the jump.
Yeah.
I've wondered about that, or if they...
Well, this is pure speculation, of course.
Yeah, there's just a lot of little... there's a lot of little things, and then there's a lot of just really big things. Like my laptop. I mean, today I plugged it in and it was at 50% battery because they keep changing my power settings. And they keep changing it where when I tell it to shut down, it hibernates. Well, this laptop goes in a bag for a week, and then I get it back out and we record. And most of the time, that's the use case, this laptop. I mean, sometimes I'll take it and I'll sit upstairs and I'll code some, but I don't do it much unless I'm traveling. And, they keep screwing with the power settings. And so if I didn't know that they were jerks about this and go plug my laptop in before I go somewhere, I'd have a dead laptop battery when I think I'm going to have a live one, just because they have changed settings. And they're doing a lot of this stuff that's like treating their users like idiots. Yeah, there's really a lot of things that are really starting to bother me. And I got burned not too long ago on my side project because I was doing it in Visual Studio 2013, which is what the rest of the team is on. And I'm not, I don't have my license through their license. I have it through my business's license. And it's like, okay, your BizSpark subscription is ended, whatever, you gotta pay. That's fine. But then there's no way to get on Visual Studio 2013 that I could find on their website. I spent over an hour looking. So I had to upgrade to Visual Studio 2015. And it's like, okay, well, these projects should work and it should be backwards compatible.
Oh, no, it's not. That's a big issue I had with my blogging.
If you add a new project, it's not. No. And you have to be very, very careful with what you do or you get screwed. And it's like, okay, I was in the middle of something when it kicked me out. And so it's just like this disruption. Like, they should warn you and say, give me 2 days or something. Go, hey, look, it's going to subscribe. Don't go, oh, hey, I see that you're typing a Lambda expression. Let me just pop up in the middle of it and just say, well, you've got to exit now. You're just out of luck until you pay. There's a lot of very extractive behavior coming out of them, and they're killing the goodwill of their user base. The other thing that's bothered me with .NET is they've missed the boat on functional programming, and they've missed the boat on parallel. I mean, I know async await, all that kind of stuff, but things like being able to set up a system kind of like what you would do in Erlang. You have worker processes that own child processes, and those can fail and you can recover all the way up, and having that built into the language to, the way that it's done and where it's like location transparent.
Well, I keep hearing a lot about
Akka does this.
Well, what I'm saying is I keep hearing a lot about functional programming with the F#.
Yeah, well, and this new .NET Core release, what I've seen so far doesn't appear that F# is as well supported as C#. Now, of course, C# is the flagship right now. So, I mean, I think I give them a miss on that, but
I think with that, it's more a MVP, minimum viable product. Let's get our big thing, what most people are using. Let's get full support, or as much of the support as we can for that, and get it out there so that we can get people
moving.
Yeah.
That's fine, but I feel like they've, there's been a series of articles going back and forth. There was one called "Why You Can't Be a Good .NET Developer."
Yeah, you sent that one to me.
And then, there's been a bunch of responses and back and forth, and people getting really angry and going, oh, well, most .NET developers are, like there's one group that's like, oh, about half the .NET developers are terrible. And, there's a huge part of people in the market now that are terrible, because a lot of the better developers have left. Because, .NET has, it was groundbreaking initially, but then they waited too long to jump on the MVC bandwagon, and Ruby on Rails ate their lunch. And then they waited too long to jump on the bandwagon of like having a proper package management system, and Node ate their lunch. And now it's okay, functional programming constructs and, being able to work with containers. And yes, .NET Core does that now, but I was hearing about Docker 2 years ago, and other people, Python people were able to get in there. And so those languages are eating their lunch. And my concern is that this is going to keep happening, and you're going to see fewer of your better devs coming in, and you're going to see more of them going out. And you don't want to be the last good dev left.
Yeah, you got to close up shop and pay the bill.
Well, or you're just cleaning up, or you spend your whole career cleaning up bad code.
You mean what you've done?
Yeah, which, I mean, I've made good money at that, but it gets old. And so I'm kind of I'm at a crossroads.
Yeah.
I'm at a crossroads with that, and I'm going back and forth because .NET Core is potentially an opportunity for things to work, but still some of the higher level constructs that I'd like to have are not available. Like, for instance, I can't do Akka.NET in .NET Core, which would be my ideal to have distributed processing. So I don't know. I'm kind of mixed. How about you? Since I'm going to
make you start editing episodes just so that you know how much effort it takes. When you're like, oh, you can just edit this out. I'm like, that's like 30 minutes of my time right there for 10 minutes of you rambling.
You'll be all right.
I'm just saying.
You do it.
It's gonna get tight with me starting a job.
Yeah, but you haven't started yet. You're fine.
Oh, yeah. I've been doing some work on my truck, kind of getting ready for drive up to Cleveland this weekend for my nephew's birthday. And then I'm going to head to West Virginia, picking up my grandmother to come help take care of my dad. I think I mentioned last week that he fell and broke his hip. Stuff like changing the oil, rotating the tires. I think I had to replace a signal light in the back. It's
IoT's time.
It sure is. Let's roll the music. This week for IoTs, I have something that's not exactly Internet of Things, but it came up in my weekly hunt for interesting projects. And I do actually do a lot of the projects I find because this is my hobby. But this is a custom Xbox controller for persons with disabilities. Caleb Craft modifies game controllers for people with disabilities to allow them access to all the features of the controller. And he does this voluntarily in his spare time. And it's just a really cool use of his creativity. For this particular project, he added buttons around the joystick area for the shoulder buttons and the joystick press, and then rubber feet to the triggers so that the person could roll the controller one direction or the other and actually adjust how far they squeeze on the trigger. Pretty simple setup, basically just 4 buttons, some wires, and the rubber triggers to attach on there. And I'll have a link to both the MakeZine article on it, and then also to his website, thecontrollerproject.com, where he talks about the different controllers he's made, how he's done it, and has a forum for people that may have kids with disabilities or even injured soldiers.
Yeah.
That come back and want to be able to play video games, where he does this in his spare time for basically cost of materials.
That's really cool.
Yeah. I just thought it was a really, really awesome setup. So who do we have talking to us this week?
Nobody.
Uh-oh.
Yeah, well, can't get one every week, right? We're not quite there yet.
We need those iTunes reviews. The more reviews we get, the higher our ranking is. The sooner we can get sponsors and give away even cooler stuff than the random swag bags that we put together ourselves.
Yeah. Well, the other thing, too, is it gives us feedback that lets us know that, we do actually have listeners, and that helps a lot for motivation. So I guess we're going to do object-oriented programming, aren't we?
To start off, I'd like to talk about a brief history of object-oriented programming. SIMULA was the first object language, basically, as it says, created to build simulations. Then a little later, Kay and Xerox Parc were enthralled by the object language. And when they developed Dynabook, one of the first PCs, they created Smalltalk, an object-oriented language for programming back in the 1970s. Moving on into the 80s, Bjorn Stroustrup. I always mispronounce his name.
I've never heard his name actually pronounced. I've read so much stuff that has had his name.
I know how to pronounce
Bjorn. It means bear.
Yeah. But yeah. Anyways, he integrated object-oriented programming into the C language, which resulted in C++. And I know I took C++ in high school.
Yep. Same here. Well, college for me.
Yeah. But object-oriented programming has 4 major principles. These are abstraction, encapsulation, inheritance, and polymorphism. Like I said earlier, these are really easy areas for interviewers to question you. Most interviews I have had, especially as a junior developer, I have gotten a question from each of these 4.
Well, also, if you look at interview guides online, the first page of Google search results, all of those, I think, at least last time I checked, had questions about each of these on there because somebody made an interviewing guide in 2001 and they just kept it because it was the VB one initially, and then they moved it to C#. They ported their crappy interview questions to C#.
Yeah, but what I've experienced with interviews is they'll start off with some very general concepts, like what is inheritance? What is encapsulation? And then they'll ask something specific like, tell me the difference between overriding and overloading in polymorphism.
Yeah.
Yeah, and then from there they get into the language specifics, which for me is usually C# and JavaScript. And so they'll ask, and they'll start broad with really simple stuff and then get more and more complex. So what I wanted to do with this episode specifically is to talk about these concepts, because I have a feeling, and Will, you can tell me if I'm right or wrong here, that these are things that you would learn in a computer science course.
Yes. Intermediate programming. Some of it too with data structures, but mostly in intermediate programming, which was, out of the 3 classes, the second one was the one where we did a lot of this stuff.
Mm-hmm. And then this is stuff that as a self-taught coder, I've had to learn these
the hard way.
Yeah, I've had to learn the hard way. I've had to learn these on my own because I use them. I used inheritance for a long time before I knew all the technical terms, the jargon around it. I used encapsulation before I knew what encapsulation was.
Well, it's sort of like our design patterns episodes in that it's a logical progression of trying to keep things from being stuck to other things. Mm-hmm. And all of these, that's really what it comes down to, with the exception of inheritance, which does kind of do that. But that's more of a, hey, I want to not write this again.
Yeah, exactly. So starting off, we're going to talk about abstraction. I have a quote that states, "An abstraction denotes the essential characteristics of an object that distinguish it from all other kinds of object and thus provide crisply defined conceptual boundaries relative to the perspective of the viewer." And that is by Grady Booch. Abstractions are basically a focused representation of an actual item. And they take complex reality and put it into terms of a simplified model.
Yeah, just bearing in mind, the whole thing we talked about, the map and the territory.
Yeah.
Because that is essentially what you're trying to do, right? You're trying to get things into a form where you can work with it and reason about it.
You're reducing the complexity, but still trying to keep the base characteristics.
Yes, and I think it's probably important here to point out that it's the base characteristics that you're concerned about.
Yes.
So one thing you'll see in a lot of businesses that's kind of a screw up is they think a customer is a customer, like a customer record is a customer. Well, to the accounting and AR department, a customer includes their unpaid balance. To the web development department, a customer is their login information. All the bits and pieces that stuff needs. Like, those are not the same thing.
Yeah, makes sense. This involves developing in terms of interfaces and functionality instead of implementation details.
Right.
And you separate by the type or the what rather than the implementation, the how.
Well, it's the best way I try to explain abstraction to people is think about plugs. For instance, I have a coax plug going into the back of my TV. Actually, no, I think that was actually HDMI. But anyway, back in the day, I had a coax plug. And now I have an HDMI plug. But the idea here is I don't care how the signal goes down the wire. I have a piece that goes into another piece, and the thing goes through. That's abstracted. I don't care about the twisted pair. I don't care about the signal wavelength. I don't care about having to bump up the signal strength. Repeater stations coming from Comcast. I just have to know that I plug this into here and something happens.
Yeah, it highlights the properties needed while hiding the rest. So you're hiding the details of an object and really only exposing the essential features that you need.
Yeah, and it's the essential features that are very particular to exactly what you're trying to do. Effectively, you're stereotyping complex things in the real world.
Yeah, pretty much. The example I have, and I have all the examples that I came up with for these. Some of them I took from the sources, and some of them are ones I've actually used in interviews myself. But example I have here is changing gears in a car. The gears will be that you want to change. You're in second and you want to go to third gear.
Right. That's assuming it's manual.
Yeah. That's what I'm saying. Changing gear in a car, manual transmission.
Best anti-theft device in the world now.
Yeah, that's so true. But your interface is the gear shift, possibly the clutch. But
hopefully,
yeah.
Some people were not real sure about.
Well, if you want to keep your transmission, yes, the clutch. Anyways, but that's your interface, and you're in second. You want to go to third. You don't know the internal functioning of how the second gear gets lifted and the third gear gets put in. You don't know that. You don't need to know that. All you know is I remove my foot from the gas. I press in on the clutch, and I move the shift to third gear, and then release the clutch and press down on the gas.
And hope the thing doesn't fall apart.
Yeah.
Since you brought up the car model, because we love explaining software as cars.
That's throughout this entire episode, dude.
But I mean, that's what everybody uses for some historical reason. I'm not exactly sure why.
Okay, well, that explains a lot, because most of the examples I found when doing the research for this were car examples, and then I had the other one the ones that I had put together were car examples too.
Yeah, well,
I think it's because everybody pretty much drives.
Yeah,
so it's something that everybody has had.
And most people are
with.
terrible at mechanical things, but they can. Somebody that's terrible at mechanics can still drive.
Yeah, exactly.
But now think about how that car is built. Before Henry Ford, cars were very, very expensive, and the reason for this is that you couldn't switch parts out, because each part's, as it were, implementation details were tied to every other part. Pieces were custom made and crammed in there and put together like it was something done by an artisan, not done by a factory worker. Well, what did Ford do? Well, he had the assembly line, but he also, had a lot of interchangeable parts, and he made that a very big core of what he did. And he was able to produce cars at a lower cost. This is the point of doing this in software, breaking down the cost so that you can focus on one piece of the code at a time and not have to reason about the larger system, so long as you manage the inputs and the outputs.
Yeah, that makes perfect sense.
It just makes software scale well. So as soon as that concept came into software, which was pretty early on, it outcompeted every other.
Well, yeah, it would.
Sort of like the assembly line. Like, you don't have artisan cars. Even hipsters don't have artisan cars.
You do have artisan cars.
Really?
Yeah. They exist.
I did not know that. I'm terrified to think about the safety hazards. But
no. These are like, we're talking super high end. You have artisan motorcycles.
They still had interchangeable parts, though.
Yeah, for the most part.
You don't have somebody like welding pieces together to make the thing, and like hand wiring all the things and hand soldering all the things. Like, there's interchangeable parts in there because the economics of scale make that a huge win. This is the way of putting manufacturing concepts into software.
I'll say most hipsters could not afford an artisan car.
Yeah.
The only place really that you still see what you're talking about is possibly with some specialty motorcycles.
Yeah, because it's so expensive. It's not affordable compared to the other way. And that's why we do this, because it actually makes it really easy to manufacture things compared to the other way.
Next is encapsulation. And with encapsulation, internals of an object are hidden from the outside view. It basically protects the object's integrity and helps to reduce system complexity.
Yeah, and I want to throw this out there that I know that sounds like the previous point, and it sounds to be like it's the same thing. I'm trying to think of a good way to put it. Like, abstraction is the way your stuff interfaces out, and encapsulation is the way other things interface in.
I like that. That is great, because I do have on here that encapsulation is kind of a form of abstraction. Actually, some of the sources that I found list 3 pillars of object-oriented programming, with encapsulation as having some of the same information as abstraction. Also within this, structural changes remain local, so changing class internals doesn't affect the outside code, and
outside code can't reach in and mangle the innards.
Yeah.
Effectively. This kind of comes into my whole gripe with ORMs. Is because not only do these things exist at a class level or at a function level, even, like especially JavaScript functions, because they have the whole scoping thing and all that, but it exists at a component level, a program level, a service level, like that. This goes all the way up, and that's one of the problems I have with ORMs, because this is allowing things to reach into the state inside the database at a way that I can't wrap around that and keep it from reaching in. And oh, by the way, my structure is also reflected in that external program. And so now I can't change it either, because it's going to break their stuff.
Getting into kind of the details of encapsulation. With it, access is restricted to accessors and mutators.
Right. And that's if you're doing state-based.
Yeah. And accessors are methods that are used to ask an object about itself. Usually these are properties with a get method. However, they can be pretty much any public method
that returns value and doesn't change it.
Yeah, that gives information about the state of an object, usually a private object. And I found one example that used a function.
Oh yeah, that's the way. I mean, that's the way we used to implement it. Was it C++ did that, and objects in C will do that. JavaScript objects, you're going to wrap it in something. Getters and setters, or accessors and mutators, if you want to use the other language for this.
Mutators are public methods used to alter the state of the object. They still hide the implementation of the object, and these usually use the set method to alter the state behind the scenes, but just like with the accessors, it can be any public method that alters the state of the object. And the example I found was subroutines.
Yes. It can also be a method that's not necessarily attached to that particular property. Like, it can be one that just has as a side effect the alteration of state. Now, I will tell you, I'm not overly fond of mutators. And the reason I'm not fond of them is what happens when you change state in an object that's accessed by multiple threads. Because now you have to make sure that the change has happened all the way through before something else accesses it. And so this is where you'll come into things like immutable objects, where you're passing the initial state, but then it doesn't change after creation.
That's true. The example that I have, going back to the cars, is we talked about the manual transmission. This is an automatic transmission of a car. It encapsulates the info about the engine, such as speed, pitch of the surface, gear, so on, into a simplified interface. Basically, the gear shaft and the gas pedal.
One way to look at it in the car metaphor, with accessors and mutators is, because you have to kind of understand both sides. Accessors are gauges. Mutators are pedals, gear shift, right? It's altering state is what a mutator is. Metaphor.
I like that. That's a good,
because one's getting things out of a system, the other's putting things in.
That's great. That is a great expansion of this example.
Yes. And so, the thing with mutators, and the reason I don't like them, is exactly the problem that you have with the clutch and the gear shift. If you have not depressed the clutch, in other words, you haven't set the state in this thread this way, when you start the gear shift, things break.
Mm-hmm.
That's why I like immutable state. I want to be able to move the gear shift and the thing go, like, do the clutch, but because there's no transactionality in this.
Yeah, okay. Now,
I understand mechanically, like, that's not a thing, which is why we have automatic transmissions now, is because people don't deal well with, with multi-threaded type approaches to things.
Yeah, yeah.
But that's essentially the problem you have with mutating state.
Next is inheritance, or reusing code of existing objects or creating subclasses. These inherit attributes or behaviors from an existing class, and reusing software capitalizes on the effort, the testing, everything that went into the original software. It also helps to eliminate redundant code.
If the work is already done and you can copy the work, you're probably gonna. I mean, that's sort of human nature. We tend to avoid work, like at a civilizational level. That's why we have civilization, is the avoidance of work. And inheritance allows you to do this in a formalized way that puts the original code in one place, so that it can be reused. But if it has to be changed, it's structured in such a way that it either doesn't break things, or if it does break them, it's obvious.
With this, you have the classes that are inherited from, and then the classes that do the inheriting. Various places call the former superclasses, parent classes, base classes. Basically, they establish a common interface.
Yeah, well, it's like genetic ancestry. Of course, in C#, it's genetic ancestry of an asexual organism, effectively, right? Because there's not two parents. It's this is one that's a mutation of the previous interface, or not really the previous interface, but the previous instance. Whereas in C++, it's, well, there's pretty obscene ways to put it. None of which can be uttered here on our PG-rated podcast.
Yeah. And then you have the subclass. This is the derivative class that inherits from another class. It inherits the complete interface and implementation.
Right.
However, there is overriding, which is where a subclass changes the functions from the superclass. And it can change any function or as many functions as it wants, but the ones that are not changed are inherited.
Yeah, one way I've seen this at a low level, because thinking about this at the high level doesn't quite tell you what's going on. Imagine that everything on an object is a property, including its functions, and it's accessed through some mechanism. In other words, you've got a piece of code that's sitting there between. When you call that code and you get the thing out, you may be getting the function out. It's almost like it's a wrapper around it. It's that's one way to think about it, or think about it as a dispatch table type setup. So,
I like that.
Instead of, you're not calling and going, here's the pointer to the function that I want to get. You're saying, here is the position in the table. Tell me what the return value is. And each new subclass overwrites some of those.
Okay, yeah.
So it's an index. And I understand that there's somebody that has written a compiler that is absolutely screaming at this explanation, but that's a useful metaphor for how it works.
Yeah, and guys, remember, when we're explaining things, we're not talking, a lot of times we're not talking to the people that
already know.
Yeah, that already know, or we're not talking to the systems developers, because the majority of our audience
is not going there.
And if you are, give us a call, email.
Yeah,
we really want to talk to you because it's fascinating.
Yeah. But it's best to think of that as it's just it's a level of indirection. And this, by the way, is why if you meet old graybeards, a lot of times, a lot of them don't like object-oriented programming concepts, because that dispatch table has a cost. Mm-hmm. Especially if you're doing, polymorphic type stuff, which we'll get into later, because you don't know what the type is. So you've got to look that up before you make the call at a low level.
And I also have on here abstract classes. And these are any class that contains an abstract method. and they're declared, but there's no implementation.
Right. That's like, and to go back to the car example, make me a car. What are you going to do? Come on, give me an answer. Make me a car. What would you do?
Make you a car?
Like what kind of car?
Like, I don't understand what you're asking.
Well, you know, if you go, okay, if I say make me a car, and you respond with, okay, here's a Ford Pinto, you're wrong, because I specified nothing, and maybe I specified make me a Ford. Well, you have part of the implementation detail. So the idea here is that an abstract class is a class for which you cannot specify enough information to make one. It's a piece of the blueprint.
Yeah. Okay.
All right. It's not the whole thing. It's like saying, I want a house that's in the ranch style, you know, but not specifying anything else. Well, if you ask a builder to make it, what happens? They look at you like you're an idiot. But if you talk to them about the general way that a ranch style house is built, you can have a conversation about it, even though it's not a thing.
Okay. Yeah, I see what you're saying. Yeah. And yeah, basically what you're saying is these are superclasses or parent classes that are not going to be objects in and of themselves, but they're going to have information that other classes inherit from.
Yeah, and you can reason about them.
Yeah, these are like abstractions. These are like concepts, or in philosophy, forms, Platonian forms, I think. Yeah. So, also with inheritance, we'll kind of hit on this a little earlier. You can have hierarchies. So, if C inherits from B, and B inherits from A, then C inherits A as well.
Yes. And this becomes problematic because you have what they call a fragile base class scenario. And that's where you have over abstracted and you have something in the base class that suddenly you need to change at the base class level. And there's 200 classes that derive from it.
Oh, I can see that being,
you know, and down this whole chain.
Yeah.
Because what is that basically? It's like being in a royal bloodline. Hey, you're kings, but you got hemophilia.
Yeah.
Like it's, you know, you've inherited something from way back there and there's nothing that can be done.
So all of us Doctor Who fans know what happened.
Yeah.
Now, and some languages, like you mentioned with C#, do not allow multiple inheritances. With
caveats, yes. In C#, you can only have one base class, but you can implement multiple interfaces.
Yes.
And people use those words in a way that's very interchangeable. And this is something I always bring up in interviews because they'll go, oh, well, you can't have multiple inheritance. It's like, well, I can use the same syntax, you know, colon, a class name, and I inherited from that class, or I go colon, an interface name, and I inherited from that interface. The interface at the C# level is very difficult to tell from a class just interacting with it. Like if you look at the IL code and a few other things, you know, like functionally it's different, but from a metaphorical understanding what's going on level, those two concepts have been blurred because what is like if I look at an abstract base class that implements no methods and I inherit from it, how's that different from an interface? Well, I have to go to the IL code to really functionally look at that and go, what's really different?
All right. So I didn't put any of that in the show notes because I wanted you to just go off on it.
Yeah.
Because I have had this conversation with interviewers where they asked if you could have multiple inheritances in C#, and I pretty much said the same thing you said, less ranty, more
it's
interviewee, but you know,
it's like I guess the way I would put it is like the abstract base class in C# is apparent, and the interface is more like a tick. It's just hanging on. But it still dictates so much about the behavior and how the piece plugs into all the other things that, like, I'm not sure that I think that's a distinction without difference in enough cases that it has to be kind of batted around a little bit. The other thing too is like if you look at older languages, like for instance, if you look at VB, which is where all these interview questions originally came from, Visual Basic 6 did not have inheritance. However, you could implement an interface.
Yeah.
And that was what they called inheritance in a lot of the books back then. Yeah. So it's one of those things like, I understand the difference at the IL level, and I understand, syntactically that implementing an interface is not the same as inheriting an abstract base class, but like looking at the code and what you actually functionally do with it, the difference is really hard to quantify. Yeah. And it's one of those things, it's like it's manufactured differently, but it works out to kind of almost be the same thing in a lot of cases, but not all. And different languages do different things. Like you could, for instance, constructors are inherited most of the time, but not always. Or it might be a thing where, okay, you inherit it, but you have to explicitly specify the child constructor and then delegate to the parent, at some point during the construction process. Or, there's a lot of things that have a bit of bleed over into the compiler implementation that you're just going to slam into at some point. And then you look at static types and going, okay, this type has got a static method on it. Am I inheriting that? Well, no, I can't do that because there's no instance. Like, get the polymorphic behavior with that. But at the same time, your IDE may, and your framework may well go, well, if I get a call to this static method on this child class, I'll just delegate to the parent transparently. It's a lot fuzzier. And part of this has to do with the fact that object orientation is an abstraction itself.
Yeah, that's true.
And abstractions leak.
Yeah. So the example, going back to our cars here, that I have, and this is one that I have used. Actually, this is what I use when asked to explain inheritance. Here's what I explain. I say the way inheritance works is you have a vehicle class. This is an abstract class, so there's no instance of vehicle. But within that class, you have a VIN, make, model, year, dealership location, color, things of that nature. Then you have classes that inherit that information, such as car, truck, motorcycle.
Right. And they all have engines in them.
Yeah. They all have engines. With car, you may have, is it a 2-door, 4-door sunroof, trunk size, things like that. Truck, you have towing capacity, you have, bed size, seating, other things like that. With motorcycles, pretty much have 1 or 2 seats. That's about it. You don't really have doors on a motorcycle. You don't have, sunroofs on a motorcycle.
Because it's not needed.
Yeah. And so each of these classes inherits from the vehicle class. And then you could have, even within that, a sedan class that inherits from the car class, which inherits from the vehicle class, so that the sedan will have VIN, make, model, etc. So, why do chicken coops only have 2 doors?
I don't know. Why do they?
Because if they had 4 doors, they'd be chicken sedans.
Wah, wah, wah.
I don't remember where I heard that, but when I was writing this, I thought of it.
Oh, man. That's so are you going to start doing the joke like .NET Rocks does, like the corny joke in the middle?
Yeah, I think I'm going to try that. We'll see where this goes.
So you're implementing their interface.
Well, I mean, come on. I stole a lot of ideas from them.
That's true.
Because they are probably one of my favorite podcasts. So, anyways, finally we have polymorphism. And I have a quote from one of the really good sources I found by Kaari Moriyangi. I am probably butchering that name, and I'm sorry if you're listening. Honestly, if you're listening, dude, awesome. But
get on. Yeah, get on the podcast with us.
Yeah. The quote states, polymorphism, a Greek term, means the ability to take more than one form. Or, as I stated in the intro, one name, many forms. And this is multiple methods that all have the same name and different behavior in different instances.
It's like I was talking about with lookup earlier.
Yeah, exactly. It's the ability to process objects differently based on their type or class. For example, the plus sign operator. If you have two integers, an integer plus an integer, it'll give you the sum of the two integers. However, if you have two strings, it'll give you a concatenation. So if you have 5 plus 5 integers, you'll get 10. If you have string 5 plus string 5, you'll get 55.
And this makes me think of a particular thing that's hilarious, and we need to put the link in the show notes.
2 plus 2 is 5?
No, where somebody was going over the way this doesn't quite work well in JavaScript because of the implementation. And the talk is called WAT, W-A-T.
Oh,
and it's available on destroyallsoftware.com.
Yeah.
And it is awesome talking about where they've just dropped the ball on this thing in JavaScript, and now it can't be fixed. Like taking an empty object and adding it to an empty array, and what happens, and then switching the order of the operands, and how those two things are not equivalent, even though that's mathematically that should be the same. But yeah, the idea is I can use the same method on different things, and it means different stuff. So like you were saying with, if I take, you were saying I can take two integers and I can add them and I get another integer. If I take two strings and add them, I get another string. And
if you take an integer and a string and add them, you get
a string or a type error. And some of that has to do with the way type probing works, because it's going to look at it and go, okay, well, you started off with an integer and you added a string, and I don't know what to do with that because I'm assuming this is an integer operation because of the first operand, because I'm kind of naive. And if you do it the other way, it goes, oh, it's a string. So the second one, I'll just convert to a string and go on with life, which is why type coercion is evil. And you'll get weird things with this too, like with comparison operators with dates. So like I worked on an e-commerce system where somebody said, okay, these things are the same, across, which is probably a reasonable assumption, except that they said, is this date less than this string? Or actually they said, is this string greater than this date? I think was the way that it worked. And what ends up happening when you have those first few days of the month where the day is a single digit and you convert that to a string and you compare it to another string, you don't get the same value as if you compared two dates.
No, you don't.
Because it does alphabetical ordering, not numerical. And let's just say that a sale started again after it was supposed to stop. Wow. Very briefly. And some people got some good deals.
Yeah.
That was uncomfortable, but it wasn't my fault, so I was all right with it. But that was...
Yeah, no, this is why these are important.
Yeah, this is why I beat some of the drums I beat so much.
Yeah. So with this, you have overriding and overloading. And overriding is known as runtime polymorphism. In this, the method used is determined at runtime based on dynamic type of an object. And new implementation of an inherited method. Basically, you can't overwrite non-virtual or static methods for the most part.
Right. Well, I mean, and a lot of this is C#, Java, because the problem I have with saying you can't is because of what I don't know what some whack-a-mole language is going to roll out with next week that lets it happen. So I'm afraid to say can't versus generally speaking can't.
Yeah. Generally speaking, you cannot or do not override non-virtual or static methods.
Right.
And then overloading is known as compile time polymorphism. And this is where the compiler determines which method will be run at compile time.
Yeah, based on which types were passed in, because at that point it gets a signature, so it's actually a different place in that table I was telling you about to look up.
Yeah. And I'll come pick you up in the vet. Now, that could mean the Corvette, or it could mean The Shovette.
But it's got bucket seats. It's powder blue.
You know what I'm talking about.
Exactly what you're talking about. Yeah, and that's an example of conversational polymorphism of types.
Yes.
So Beej and I had a discussion in the middle of this podcast episode, which has been faithfully cut out, but we're adding it back in at the end.
Yes.
And if you'll remember, we had an episode on April 1st about how the map is not the territory. Or that wasn't, the whole point of the episode, but that was one of the points that was raised. And this is one of the places this comes in. Object-oriented programming design is a map, not a territory. Beej used the car for the example of inheritance, for instance. So let's say, we said that, this type of, like a Ford inherits from, or let's say a car inherits from a motor vehicle. And then, your particular type of car inherits from that, your particular, make, model, year. And of course, it gets a little weird there with that structure. But for a database of cars, or a thing where you're dealing with cars going, okay, well, how many wheels does it have? Who owns it? It works.
Here's another thing that we didn't think about under motorized vehicle. A boat.
Yeah. That's exactly where I was going. It's, that's a different branch, but then you've got weird things like James Bond's car that can drive into the water and go and just go.
And
I forget what model that is. It's something they only made like 4 of or something, like in the 60s.
Well, actually, one of the new Tesla cars.
Of course it's a Tesla.
Can float.
Yeah. But the other, right. So like if you're dealing with it in a vehicle database sense, a car is a car. But if you're dealing with it in a mechanical sense, that's not the same, because it's a composite. Like you would look at a car completely differently. It is the interaction of its components that it is built by composition of. And if I'm looking at it from a perspective of actually constructing one, it's even worse, because now I have, essentially those components can be switched out, and I could potentially have, well, let's say Ford has, 2 cars, same frame, same structure and everything, same size and all, basically all the pieces, except one of them has got a diesel engine and one has got a gas engine, right? They're going to get 2 different model numbers, but a fair bit of the mechanics is going to be the same, but not all of it. So it's important here to think about like object orientation. It works in the space that it works.
Yeah. Well, it's interesting you're talking about that. I think of when I learned to paint. You're not a painter. You look at a painting and, if you've taken art history or something in college, you look at a painting and you can go, oh, well, this is this style, this is this style, things like that. I learned from my dad, who's a great artist. I look at a sunset not as, a beautiful sunset, but I look at it as layers of colors.
Yes. And
how I would paint that, and then, the different layers of that. And it's an interesting thing. It's kind of like a mind warp. When he taught me how to paint, I started seeing the world in layers of colors. Yep. I'd be driving down the road thinking, oh, I would paint the white of the clouds after I painted the light blue, but before I painted, the skyscrapers in Nashville,
And I did, for a while there, I was trying to do pencil drawings a lot. And the way that I looked at things was the reflection and refraction of light.
Yeah.
So, you draw the curve of an orange, and then you think, okay, well, there's a light, it's laying on a surface and light's hitting the surface and it's going to reflect up. So I draw a shadow, but there's like a light edge underneath it. And that interaction is something that you don't get. It's an abstraction in this context, but over here in this other one, it's not useful. And
I think it would be interesting to possibly have an episode on how art, even if you're not a good artist, but just learning the concepts and the practical concepts, not the art history stuff, but the practical concepts of art can help you as a developer in just your mindset.
Yeah, and being able to, because the thing is like with object orientation, the useful thing here is to be able to switch perspectives to, okay, what is a customer in this situation versus what is a customer, because things are not fixed, and being able to pop that mindset off and do something different. And I know I'm not explaining this very well.
Well, I'm getting what you're saying, but then like I'm on the same page as you. So
yeah, the car metaphor and the reason it's not so much, I guess, I said before that I wouldn't use it in an interview. I probably would, because everybody understands cars at some level and then they don't understand them at some level and find them frightening. And abstraction and polymorphism and all these things are ways to basically hide the fact that you're going to lose an arm or a leg if you stick it in the engine while it's running.
Yeah, that's true.
But the problem is like the way that you self-process it can get in your way, because like for instance, the car metaphor and why this has come out, like there's been rant after rant on the internet about it, is because of the issue of implementation via inheritance versus implementation via composition and how those pieces interact, because that gets messy, which is why you have multiple inheritance in C++, right? The thing is not a thing. It's the interface of itself with something else. And it's a set of those. And almost everything is more like that. And so modeling reality gets very messy. So these things are for a problem within a particular space, not for, like, they're not general purpose semantic models. Like if you look at them that way and go, then you'll be okay. But if you go, okay, I've got to model this object exactly, you're going to have the worst code you've ever seen in your life.
Yeah, I completely agree. So that pretty much wraps up the episode on the major principles of object-oriented programming. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
I'm going to run with something that kind of came up to this episode. We're talking about objects and how you model things. We discussed implementing or inheriting from a base class, depending on how you want to look at it, as one way to build things. But the other thing is the idea of composition that I was talking about. And that's also a very valid model. And you'll find in a lot of languages that don't support inheritance or have single inheritance that this tends to be the way a lot of things get done, because it enables parts to be switched out from the code. And I know this is kind of tricky to explain, but in the car example that we discussed before, you might switch out a diesel engine for an electric engine. And obviously, this doesn't really work very well in the real world because of weight constraints and all the different things. But assuming that you had a universal interface for those engines that was the same size and you could plug and play, you could build it by composition. This way of working with things, in my experience, tends to be a lot easier than inheritance because of the fragile base class problem. Because it's easier to build things out of a collection of components than it is to inherit. Most of the time when you're using inheritance, it's potentially dangerous. It's not that it is initially, it's that it's the trouble you get into when you deeply inherit things. So think about how your model for reality can, or not necessarily for reality, but think about how your model for how a set of objects interacts can be tilted on its side and looked at in a way that is possibly less risky. And I find in general that inheritance and mutability are two of the things that create the most risk. So that's what I got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.